So what is the problem? Based on a study done by Fairhurst and Harter, 30% of the costs in plantation are due to the fertilization materials. While that is the majority of costs, the transportation and harvesting costs combined contribute to 32% of the costs. And we aim to tackle these two areas. This is because the time taken to examine and harvest mature palm trees takes about 7 to 13 days. However, a study done on a drone-based plantation in Genting had shown that time taken can be reduced by 2,436%. So what was the job for 7 to 13 days can be simply reduced to 4 to 7 hours. And by reducing the time taken, we can also reduce the ratio of labor costs to a ton of palm oil revenue, which is currently at 25.5%. To tackle the problem stated just now, we have come up with an innovative idea, that is a drone-based system that maps the palm plantation while monitoring the growth and ripeness of the palm fruits. So how does the drone work? It first maps the entire plantation and it marks down the location of the palm trees and roots of the map. After that, the drone can autonomously plan its path to periodically check the palm trees to see if any fruits are ripe. This is done with a camera, where it takes images and is processed by a pre-trained AI on the drone's computer. If it verifies that the fruit is ready to harvest, the computer will take the drone's coordinates and store the location data in a server. And the data processing is explained here, where the drone's sensor and image data is sent to a private server called Fog. The data will then be stored in the cloud while also sending it to the devices of the end users, which are the plantation workers and owners. So here is our drone prototype. It's a quadcopter installed with sensors, a camera, and a computer to make it autonomous. As mentioned, the drone uses AI to verify the fruit's ripeness, but we also have a Pixie Cat, which also has an AI to identify the colors in the image. These two AI are combined to further improve the accuracy of the ripeness and reducing any false positives. And here we have a few demonstrations on how the mapping, ripeness detection and sensors work individually.
So, how does this impact the agriculture industry? Drones provide a coverage of 2,500 hectares a day, which is 500 times more than the average coverage of one worker. And thanks to that, it can effectively cover the fruit searching task of 20 workers at a time, as the time taken to search and verify the fruits are also much shorter. Also, as long as it is charged, the drones can work 24/7 without much rest. This effectively saves a lot more time and reduces the cost of time-based resources, which is much more efficient than the traditional methods. And here is a table that shows the calculation mentioned by the previous points. By implementing drones, we can save 44,000 ringgit, provide 500 times more land coverage in a day, and reduce the fruit ripeness verification time by 12.8 hours. As for the commercialization potential, the drone itself has been certified a technology readiness level of 6, which means it can officially be commercialized into the market. This reduces the time needed for testing in the future and can immediately be deployed the drone and the solution for commercialization. For market analysis, we can see that Malaysia contributes to 28.5% of the world's palm oil production. As such, our drone innovation is very marketable in the Malaysian agriculture industry. And additionally, we can see that there has been a growth in interest of palm oil production, in which the revenue in 2021 to 2022 was 67.3 billion, while it has further increased to 70.3 billion this year. This, combined with the steady increase in palm oil consumption, can ensure that our innovation can be sustainable in the agriculture company, while further boosting its production quality.